Hello, 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 everybody. I hope you're ready for question number 22 on the 2008 grade 11 Fermat paper. So let's take a look at question 22 here. For how many integers k do the parabolas with equations y equals negative 8 or negative 1/8 x squared plus 4 and y equals x squared minus k intersect on or above the x-axis? Ooh, okay, on or above the x-axis. So we could, so in terms of intersection, how do we normally find intersection? Well, we set these equations equal to one another. Now we don't know the value of k, that's fine, but we can we could rearrange, solve, and get answers for what could x be in terms of k. But then we have to ask ourselves, okay, we're not so concerned with the x values. We're concerned with, because I'm pretty sure these parabolas will intersect. This one here with the negative 1/8 is sort of a downward facing parabola. This one here with the x squared is more of an upward facing parabola. So I would expect that they would intersect. Not always, because if the k value is really, if the k value were very negative, I suppose it could be up here. But assuming they do intersect, the question then is, what is the y value? Because the y value tells you whether or not you're on, that would be y equals 0, or above, that would be y is greater than 0, the x-axis. Okay, so that's the task here, and that's what makes this slightly harder, I would guess. All right, well, let's start off by intersecting these two parabolas. So we have negative 1/8 x squared plus 4. It was plus 4, right? Yeah, plus 4. And x squared minus k was minus k, correct? Yeah, minus k. Okay, so we've got these ones intersected. What am I going to do? I'm going to bring the k over to the other side, k plus 4, and I'm going to get all my x squareds together, and that'll make this 9/8 x squared. Because remember, this is 1x squared plus an 8th. So 1 plus an 8th, that's 8 over 8 plus 1 over 8. That's 9 over 8. All right, so what can we do? Well, we'll get 8k plus 32 all over 9 is x squared. And now, so we can square root both sides. So x is going to be, going to be over 3, and then it'll be plus or minus the square root of 8k plus 32. Now, we should make a note that we only have intersection, or they only intersect if you can actually take the square root. So if 8k plus 32 is greater than or equal to 0. Because if it's negative, that's not going to work out so well. And so that means 8k has to be greater than or equal to negative 32, or k has to be greater than or equal to negative 4. And this makes sense. The highest point on the first parabola is going to be 4. The lowest point on this parabola is going to be 0 and negative k. So you'd want so you'll stop intersecting if if negative k is greater than 4. Right? If negative k is less than 4. Wait, what? No, if negative k is greater than 4. Yeah, if negative k is greater than or equal to 4. So what did I do? I feel like I did something wrong, because dividing by negative 1 should flip this. Oh, no, okay, no, we're fine. So we have a problem the second that k is less than negative 4. There we go. Okay. All right, so this is actually pretty important right here. We have a condition on k. I think k had to be an integer, not necessarily positive. Yeah, integers k. So so what we need to then do is figure out sort of like, could k be at most 7 or something? And then that would tell us what values we're looking at. Okay. So, assuming we have an intersection, so assuming k is greater than or equal to -4, we can get these x values. They're where we're going to intersect. But then what is the y value? So the y value needs to be greater than or equal to 0. And this, I think, is going to be the start of our next condition. So the y value has to be greater than or equal to 0, otherwise you're not intersecting on or above the x-axis. But y, for our intersection, is the same as -1/8 x squared plus 4. So that needs to be greater than or equal to 0. But now I can plug in, well, actually I could plug in what x squared has to be. So -1/8, 8k plus 32 all over 9 plus 4. So that has to be greater than or equal to 0. We'll flip the page and divide by 8 on top and bottom, so we'll get -1 k plus 4 over 9 plus 4 has to be greater than or equal to 0. Just want to make sure I copied that right. Yep. Okay, and now I'm going to divide by -1, and this will flip the sign. So k plus 4 over 9 minus 4 has to be less than or equal to 0. Let's bring the 4 over to the other side. So k plus 4 over 9 has to be less than or equal to 4. K plus 4 has to be less than or equal to 36. So k has to be less than or equal to 32. So there's that expression. And when we combine it with the k has to be greater than or equal to -4, there we go. So we just ask ourselves, all right, what can we do? Well, let's add 4 to both sides. I just want to figure out the number of integers in this range. Actually, let's not muck about with that. There's an easy way to tell how many integers are between m and n inclusive. So the number of integers. Okay, and if you haven't seen this, it's a nice little thing to have in your back pocket. N minus m and then plus 1. Think about it. How many numbers between and including 1 and 20? You might think it's 20 minus 1, but you're actually counting every number except 1. So you add 1 on to fix that up. It's the same sort of principle here. N minus m plus k, so the number of k that are integers is 32 minus -4 plus 1. Okay, and that'll be 36 plus 1. We're looking at 37. Is 37 one of the possible answers? Yeah, there it is on the end, E. So we're going to bubble in E on our Scantron sheet, and we can move right along to question number 23. I will see you for that in the next video. Until then, thanks for watching, and do take care.